Hi there, this is Professor Eckhouse, and I'm going to continue our conversation about systems of equations by talking first about real-world applications. The most common one to talk about with this is cost-revenue function, so that's where I'm going to start. So revenue is how much a business brings in, and cost is how much a business spends, the cost of doing business, right? So let's talk about what each of those might look like. So revenue is going to be R equals sum x times p. Okay, that's going to be the orange line, the revenue line. R equals sum x times p. Well, what are x and p? X is the quantity sold. You could also use N or anything you want, really. Quantity sold. And P, again, you can use anything, but I use P for the price per item, right? The price per item. All right, so the quantity sold and the price per item. You could also see that as PX, right? R equals PX. Either way you see it, it is how much money you bring in by selling things. All right, the blue line here is the cost. That is how much the business spends. So when you open a business, you start out with costs, right? You have fixed costs, so fixed costs, and you have variable costs. So what are some of those things in a business? Well, you can think about it, but fixed costs are things like rent. Salaries are sort of fixed, salaries, things like that. And variable costs can be things like utilities, right? So these are things that businesses have to pay that's going to take away from the revenue, right? So if you look at this graph here, we've got the quantity in hundreds of units down at the bottom and the money in hundreds of dollars over on the left. So quantity and money, the number of things you sell and the money that you either spend or make, right? Depending on which line you're looking at. The break-even point is going to be the point at which the business brings in as much money as they spend. So where is that? That is where they intersect. So that's the intersection of cost and revenue. So in other words, it's where revenue equals cost. And that's really important. Really important. It's where revenue equals cost. So you've got an equation for revenue, an equation for cost. If you set those two equal to each other, that will be the place where it breaks even. All right, so let's look at an example. Given this cost function, where is the break-even point? All right, so if you had a cost function, and I'm going to show you a graph of this in just a moment, you've got C equals 0.085x plus 35,000, and R is given as 1.55x. And what is X? Well, X is going to be the number of units sold, right? So that's generally what X is going to be. Your unknown is going to be the number of units sold, because your income and your costs, the cost of building things, is going to change depending on how many units you make, right, or sell. All right, so X is the number of units. All right, so the break-even point, so find the break-even point, that is going to be where R equals C, right? So we have to set C of X equal to R of X. All right, well, C of X is just 0.85x plus 35,000. And R of X is just equal to 1.55x. So now we've just set them equal to each other, and we just have to rearrange. All right, so I'm going to subtract 0.85x from both sides. And I'm going to get 35,000 equals 0.7x. Now we're going to divide both sides by 0.7. And I'm going to get that 50,000 on the left equals X. So that means that we are going to break even when we sell 50,000 units of whatever this is that we're selling. So break even when we sell 50,000. Now the question might also ask, then how much money are we going to be making at that point? Or spending, right? Either one, we're spending and making the same amount. That's our break even point. So you could plug it into either one and find what that amount is. So I go for the easy one, right? I'm going to say R of X equals 1.55 times 50,000, because that's my equation, 1.55x. And I get that I'm going to be making $77,500. $77,500. I'm also going to be spending $77,500, so that is my break-even point. And how could you make sure? Well, plug it in to C of X, right? And you get 0.85 times 50,000 plus 35,000, and you get 77,500, right? So both are the same. That's the break-even point. All right, so here is the graph of the two. Right, we have the quantity sold down here and the dollars over on the left. The cost is the orange one, the revenue is the blue one. All right, so now where is the profit? Now, if you want, we are going to get into inequality soon, and the profit is going to lie right in there. All right, but right now we're just looking at the break-even point. All right. The cost of a ticket to the circus is now this is not a cost revenue. This is a different kind of problem. You're only going to see two kinds of problems in the homework, and that is one almost exactly like this, and then a cost revenue problem. All right, so cost of a ticket to the circus is $25 for children and $50 for adults. On a certain day, attendance is 2,000 and the gate revenue is 70,000. How many children and how many adults bought tickets? All right, so here's the thing. You got to figure out what your unknowns are going to be. So I'm going to call children C and adults A. Okay, so A equals the number of adults and C is going to be the number of children, because that is the question, right? That's the unknown. All right, so the first thing we got to do is come up with two different equations, and then we set them equal to each other in these kind of problems. Okay, two different equations, we set them equal to each other. All right, so we've got C plus A is going to be 2,000. All right, so the first question is how many people total, right? And that is 2,000, right? 2,000 right there. So we've got C plus A equals 2,000. Right, that's our first question. All right. The next one is how much money. This is the best way to think this through, I think. How much money? So the money is going to be that the children are 25 and the adults are 50. So every time a child comes in, they're going to make $25. So 25 times C. 2 children is going to be 50, 3 children is going to be 75. So that's how you set that up. And then every time an adult comes in the door, they're going to make $50 per adult. So 50 times A. And they made $70,000. All right, so now we've got two equations, two unknowns. Now we can solve. And we're going to use substitution because that's all we've done so far. So I'm going to solve for A here. So I've got the adults equals 2,000 minus C. Now you can remember, you can now just take this A and plug it in right there. So I end up with 25C equals, plus 50 times what A is equals 70,000. I'm going to take out the dollar sign. So our A was 2,000 minus C. All right, so we've got 25C plus 50 times 2,000 is 100,000. Double check you did it right. Let's see, 10, and then, yep, that looks good. Minus 50C equals 70,000. All right, so I've got negative 25C equals negative 30,000. Divide both sides by negative 25, and I get C equals 1,200. All right, so now I know how many children, 1,200, but we had a total of 2,000. So now I need to put that back into my equation for adults. So I'm going to say adults is 2,000 minus 1,200 kids equals 800. All right, so that's a point. right? So our point is 800, 1200 on a graph. All right, so if you were going to graph it, you would find children down on the right, adults, so I just graphed it with children as the x and adults as the y. And this is the point where they cross. Right? So that is how you use two equations to solve when you're given enough information that you can create two equations. All right. Next, we're going to look at solving systems by elimination. All right, so again, these have examples on them, so you can go check your answers, but I do recommend when you start doing the homework to do this by elimination if it says to, and then go plug it into Desmos and see if you got it right. This is also called addition or subtraction method. The goal is to line up the equations and add to eliminate one variable. You can also subtract, but subtracting often causes problems with negative signs. All right, so we've got x plus 2y equals -1. Now the key here is to set up everything so that everything lines up nice and neat so you don't miss anything, because it's so easy to mess these up if you're not paying attention. All right, so I'm going to add these two together because I see if I add x and -x together, they're going to go away, right? They're going to go away, so I don't have to change anything. So I'm just going to add these together, and I'm going to get, remember this is a 1, so I get 3y equals -1 plus 2, plus 3 is 2. So now y equals, don't be afraid of the fractions here, right? Y equals 2/3. All right, so y equals 2/3. Now we just have to plug it in to get an answer into one of the other two. It does not matter which one you pick because we're finding the place where they cross. So I just picked the second equation. I'm going to use -x plus y equals 3. So -x plus 2/3 equals 3. And I get -x equals 3 minus 2/3. If you have the TI calculator that I recommended or anything else with a fraction on it, you can just use that to do the fractions if you want to. And you're going to find that -x equals 7/3. So that means x equals -7/3. Woo. -7/3. All right, so now I need to find what y is. Give myself a little more room here. Find what y is, so I'm going to have to plug that back into something. Oh, nope, sorry. I got distracted. So here's my answer. I've got x and I've got y. So I've got -7/3, 2/3 is my point. Okay, so that is my final answer. They both lead to that. All right. So how would you check this? Well, you would check it on Desmos. So method 1 is to plug both of them in to the other equation. But when you're dealing with fractions, I am just going to say use Desmos, right? Use Desmos. If you really like your graphing calculator, you can use that too, but I highly recommend Desmos because it just shows you so much more. So let's go open that. And we're going to see that they cross at -7/3, 2/3. All right. All right, so let's go back to that. So continuing on, example 9. So let's try this one. All of these just require some practice. You just got to practice. So what I see first is I'm going to look at my x's, and nothing is going to subtract or add out, and the y's, nothing is going to subtract or add out. So what is the easiest way to deal with this? The easiest way is just pick one that has a 1. This one has a 1 in front of it. So that means I could multiply this one down here by -3, both sides, every single thing by -3. Okay, so I'm going to rewrite the top one. The top one is 3x plus 5y equals -11. Now I'm going to multiply every single thing by -3. And you can, think of it like this, the two separate sides, or however you want to think of it so that it works for you. And I get -3x plus 6y equals -33. Okay, and I'm going to add, right? Let me use a different color. I'm going to add the two together. Okay, so I just combine them, basically. Okay, so now this one is going to go away, and I get 11y equals negative 11 plus negative 33 is negative 44. Divide both sides by 11, and I get y equals negative 4. All right, so y is negative 4. Which one could I plug into that would be the simplest? I think the lower one is easier because x I won't have to divide by anything. So I'm going to say x minus 2y equals 11. Go back to your original equation. X minus 2 times, now I've got my negative 4, I'm going to plug it in. Negative 4 equals 11. So x plus 8 equals 11, so x equals 3. Okay, so I've got my two parts to this, and now I need to write my answer. So my answer is the solution where they intersect, right, to these two lines, is 3, negative 4 at that point, 3, negative 4. So now go check on Desmos and see if you can tap on the example 9, go see what it looks like. All right, example 10. So this one, as you can see, there are no ones as coefficients. So we're going to have to deal with that. And there are multiple ways to do this. You just have to pick which one you want to eliminate. Pick which one you want to eliminate. So I chose the x to eliminate. Okay, so that means that I'm going to have to multiply the top one on both sides by 5. And I'm going to have to multiply the bottom one on both sides by 2. Why is that? So that I can get on this one and this one a 10. Okay, so that's my goal. So I'll write the purple one, the first one, and I get 10x plus 15y equals negative 16 times 5 is negative 80. And the green one is going to be 10x. Oh, what should I do? Those are going to add together. And I like to add instead of subtract. So what if I did negative 2 on both sides here? Negative 2. So how about that? We'll do negative 2. I have some weird things happening here. Now I've got negative 2 times negative 10 is positive 20y equals negative 60. And now I get to add. So it just makes it easier when you don't have to subtract. All right, so now when I add these two together, I get 0. I add these two and I get 35y. And I add these two and get negative 140. All right, so one equation with one variable. Now all I have to do is divide by 35. And I get y equals negative 4. All right, so now I need to plug that into something to find a solution. So I chose the top one. Go back to the original equation, 2x plus 3y equals negative 16. So I'm going to use that one. It doesn't matter which one you use. You'll get the same answer. And I get 2x plus 3 times negative 4 equals negative 16. I honestly just pick the one that has the smaller numbers usually, so I can do it in my head. All right, so I've got 2x minus 12 equals negative 16. Add 12 to both sides. When you have negatives, I would definitely write it down. 2x equals negative 16 plus 12 is negative 4. So x equals negative 4 divided by 2 is negative 2. All right, so I've got both parts, and I'm going to say that the solution is the point, negative 2, negative 4. That's where they cross. And again, you can go check out the example on Desmos. All right, so solving equations with fractions. The goal is to just clear the fractions first. We've gone over this already because I wanted you to see how to do it and have some practice with it before we got to here. You're going to do this separately for each equation and then use elimination or substitution as usual. We're going to use elimination, I think. So. All right, so what you want to do is you want to find the least common denominator of the first one. Okay, so let's just work on the first one. And we've got x over 3 plus y over 6 equals 3. I'm giving myself lots of space to work here. All right, so what is the least common denominator? And I see that it's 6. So I'm going to multiply every single thing by 6 over 1 or just 6. It doesn't really matter. If, like this one, I'm just going to do 6. And let's see, make sure I'm not making any mistakes before I move on. All right, that's the least common denominator. So now we get 6 divided by 3 is 2, and 3 divided by 3 is 1. So I get 2x. The whole goal here is to get rid of the fractions. So if you didn't get rid of the fractions, you did something wrong. All right, so then we get y equals 18. So there's our first equation. Okay, that's a nice simple equation. Now let's go do the other one. We've got x over 2 minus y over 4 equals 1. All right, so I am going to say, what should I multiply both of these by? And I see that it's going to be 4, or 4 over 1. That's the least common denominator, 4 over 1. And so this side I'm just going to say times 4. All right, so 4x over 2 is going to be 2x. And 4y over 4 is going to just be y. And that equals 4. So look at that. Now we have two very nice simple equations. And even look at the y's. I've got plus y and minus y. So I'm going to take this equation on the right. I guess I won't move it. I'll just rewrite it. And I'm going to put it underneath. So 2x minus y equals 4. And now I'm going to line them up and I'm going to add. Okay, so I get 2x plus 2x is 4x. Y minus y is 0, so that goes away, equals 18 plus 4 is 22. And we are going to divide by 4. So we get, divided by 4, x equals 22 over 4, which is 11 over 2. 11 over 2, or 5.5, if you're going to go graphing it. Okay, so now we need to put that back into one of these equations. So I'm going to pick the, let's see, the green one. So I'm going to take the green one and I'm going to plug it in right there. Okay, so I get 2, and I do that because I see the 2's are going to cancel out. I get 11 over 2 minus y equals 4. So now I get 11 minus y equals 4. So minus y equals negative 7. And then so y equals 7. So what is my point? My point is, solution is a point, is 11 halves 7. Okay, so that's my solution. And now you can check by going to the graph that I've done for you, or go make your own. Go see if you can start putting these in yourself and find what the solution is. All right, so a couple special cases with elimination. Because you will see some of these. Let's see. So how are we going to eliminate the top? So I see the x's. If I did it times negative 3, top and bottom, negative 3 times negative 3, I'm going to get negative 3x minus 9y equals negative 6. You may be seeing what's happening here. And then I've got 3x plus 9y equals 6. So I go to add these together, and lo and behold, I get 0 plus 0 equals 0. That means there are infinite solutions. Let's go look at this one. So I want to show you this one. All right, so this one is, there's one line, and there's the other. Get rid of that one, put it on, get rid of that one. They're the same, right? So the same line. And this is just an example of two different, arrangements of the exact same equation. Okay, so another special case, and I believe that this is the last one. So you can see that we've got these same numbers here. So let's just see what we can do so that we can make it so it subtracts. So I'm just going to say times negative 1, right? Times negative 1. And I get 2x plus 7y equals 14 on the top one. And the bottom one, I get negative 2x minus 7y equals 7. So I get, when I go to add this together, I get 0 plus 0 equals 21. So 0 equals 21. Well, that doesn't make any sense. So there are no solutions. And you may have seen that these have the same, when you look up at the equations, you might see that, sorry, that looks like -1, so I'm going to put those around it. You may see that they have the same slope. So these are parallel. But if you get something like this, it means there's no solutions. This is an inconsistent system. No solutions, parallel. So again, let's go take a look at this one so you can see what's going on. One last thing. And you can get to all of these graphs yourself, but that's what they look like. There's the two lines. All right, so thank you for watching. I believe this is the last one. All the graphs can be found on Desmos by clicking on that link, or you can click on the individual ones. All right, thanks for watching.